get started because already two people are waiting there.
Hi. Yes, I can hear you.
Yeah, live streaming seems to be on now. Yeah, Vishal, I can hear you. That's live YouTube is working. Yeah.
All right, let me see. So where's the button? So do I need to turn on camera? Is that the usual way? I'm not sure. All right, let's check. All right.
You are now muted.
Just a moment, my system is being slow. Okay. So is it visible there, right?
You
Yeah,
are now unmuted. You are now muted.
All right, so let's start. So hi everybody. Thanks for Vishal for introducing me and giving me the quick opportunity for giving a quick introduction about the open standards and open media. All right, so let's start. So this is a very vast topic to begin with, and I'll be trying to cover most of the things in like a very nice way, even though these things will be like sometimes a bit complicated. So feel free to post in the middle so we can have the questions. So as it is a casual talk, I don't mind posing right after the
open
slides and
standards and open media.
having clarification about
so-
something. So I think that may be more better than the usual way of having the questions at the end. And we can have the questions at the end too, but you can also post in the middle. So yeah, the slides are also online. Maybe I can post the link in the chat if you want to refer. If the video is being slow, that can be useful for people to read that over time. All right, so let's get started. So I'll give a quick introduction about me. So my name is Vibhuti, and I'm also active contributor in the various open media, multimedia projects like VideoLAN, Zip.org, and Trust AV. These are the main things which I try to become part of. Like, so I started back in like 2016 from my university, home university, Amrita. There's a FOSS club in my university called FOSS. So I'm being has started bootstrapped towards open source from the home university. So was doing a lot of things since then. Yet right now I'm a graduate student doing postgraduate PhD in Trinity College, and also I'm working in the electronics department as a research assistant in parallel to PhD. So we've been doing a lot of research with the AV1 and open media and related to open standards generally from the department here. Right, so you can reach me out via email or Telegram or Twitter or anywhere where you want. Right. So what are we going to talk in this next 20 minutes? Hopefully. Right. So we'll be giving a brief introduction about the video compression. We'll be also talking about AV1, and we'll be giving a slight overview about AO media. And lastly, like how the team and the how you can collaborate and contribute towards the open standards efforts. That's the last thing which I will be giving a quick overview, right? So let's get started. So video compression. So how many of you, I assume people may have heard about it or seen about it. So basically video compression is like the process of compressing one input video and making it like the smallest one, retaining the quality. That's the simplest way we can say what's the video compression. So even though it sounds trivial, it's one of the most complicated things, and it involves a lot of maths, it involves a lot of signal processing, it involves a lot of research and science. Yeah, it's classic digital signal processing are the behind the scenes of a video compression. Like you take the input video, you do a lot of filters, and you have a lot of intermediate steps to get the final result, retaining the best input. That's the simple way to have an overview about video compression. And yeah, one thing is like this is super hard. And next thing is like, even though this is like 2021 codec or 2020 codec, which you see, the core idea of this, which is implemented maybe back in 1980s or 1990s, even the work which we do in 2021, the papers which we are referring are back in 1980s, 1985, 1990, and that's the still the thing, right? And even if you see the code base, it's some of them might be like verbatim copy since 1990, and something like the variables or offsets or something inside the code base will be constants, which is untouched since then. So there are like millions of rooms for improvement inside this. So like you can see, this is a simple example. This was taken from some of the old work which I did. So basically, this was a video. So this is called duck takeoff. So this is a zoomed in picture of one block inside the video. So you can see here in the left, that's the initial compressed version. That's around like 7 megabits. And later you try to have some hacking to make it better inside the codec to make it like at 6 megabits, 6.5. And yeah, you can have it like, you can have this visually same quality at like 5 megabits. I tried to have like a same quality or slightly better than the 7 megabit version at 6.5 megabits. That's this thing. So on the metrics, the the second version was having the objective metrics was having slightly like around like 2 decibels better quality, 2 or 1 decibels, right? So I will just have a quick pause to see if there is any questions or things from the people.
What is
Hey,
how do you measure the quality? You said the decibels. Could you explain what does that mean?
oh yes, sure. So decibels. So most of the time there is like objective metrics called PSNR, SSIM, and tons of metrics is there, and all the standard units is called in decibels. The noise. So basically, what we do is that we take for measuring the. Usually, there in the picture, usually we have heard like a RGB, right? Red, green, blue, and in this case, there are three things. One is like YUV, one is chroma, and the other is blue, and the other is red part of the picture. So we divide the whole picture into three components. It's like, so one is Y component, means like the black and white version, the color, and the brightness. That basically I will say like there's luma component which takes the brightness part, and the chroma component which takes the color part. So we take the individually, we take the brightness part and measure the initial brightness of initial source, and then compare with the compressed source and see what's the difference between both. It's basically doing, it's not simply a negative of both, but there is some logarithmic computation of both, and then we'll be getting some value like 35 or 40 decibels of the source, and we'll be doing like 42. So if the B is having like 42, it's like 2%, 2 decibels is improved in the noise ratio. That's something which I thought like I'm not sure if this is clear.
Yeah.
Are you?
Yeah. Thanks for clarifying that.
All right, thanks. All right. So is there any other things? So do YouTube people, if they have comments, will they be visible here, or do we need to go there?
I think you can carry on.
Sure. All right. So right now, current traffic of the internet estimated by Cisco is around like 80% or more than 80%. That's a study from Cisco. It was in 2016 or 2018. They do periodic study of the internet traffic, and they currently estimates like in 2021 there are more than like 81% of the internet is video. And even though in that more than 35% of that is adult video, that's another fact. And right, so inside this video compression, most of the use format is for almost all video use case, like what we are seeing now in the talks on the YouTube, or like when you do the screen recording, or all the distribution of the video is mostly something called AVC or H.264. That's the kind of golden standard which industry people use for almost all use cases. So there was a study from a company called Bitmovin. So they have estimated that the H.264 is having around 91% of the people in the internet broadcasters use H.264. It's like they are not only using that, it's one of the things. Even in the case of YouTube, when they do the transcoding, they do around H.264 is there, then some other modern codecs like VP8, VP9. VP8 is not the VP9, H.265, etc. Oh wait, so again I just missed one point in the behind. So in the video encoding is there. So like there are three things. So and I mentioned transcoding, I assumed that. So one thing is here, like encoding is the process of compressing the thing, right? And the second thing it involves is like there's something called deep, which is just the opposite, doing the reverse process for playback. That's decoding. And the third thing is called transcoding, which is basically converting from one format to another. So for example, you have a full HD video and you want to make that to 720, and you will be re-encoding that to make it 720, and that process is called transcoding. So in the case of YouTube's and all, they take the video and they do the transcoding to 720, 1080, 480, all the resolutions, and that's called transcoding. And yeah, that's one thing which I mentioned. So coming forward, so H.264 is standardized in 2003, and if you see in 2003, other things which were standardized was not. It was around was the old BlackBerry phones and the old classic ThinkPad laptops. I think that's from IBM. I'm too young for that. Right. So there are different encoding standards and codecs which determines the whole encoding usage. So the thing here is like most of them are not royalty free and require significant cost for usage. So this is kind of jargon word, royalty free. So what does it mean? Like you have a software and you are using some specific algorithm for doing some process, and that algorithm might be patented by some individual or some company. And for using that patent, you may require to pay some money for them. So all the encoders may be having like 20 or 100 different patents or even more. And altogether that costs a big chunk of money to use that. So to manage this whole business, there are some different bodies all over the world in video compression. That's MPEG-LA. That's a independent business body for collecting monies and distributing to the patent owners. So like for a commercial license for HEVC or H.265, it's like if you are selling for more than 100K units, you may need to pay like 20 cents per unit for each unit. So till 100 cents, you don't need to pay any money. And once there's a cap of like 25 million per year. So in the case of Apple, they sold more than 35 million in a single quarter. And by a year and a half, I think they reached the cap of 25 million. And that's the end of the Apple paying the royalties. And then they don't need to pay any royalties. So even the case like if you are trying to build a commercial application for video encoders, like if it uses some compression forms, you may require to pay the license from the MPEG-LA or some other things if you are not using a royalty-free codec. So if you are having a video streaming platform or like video licensing or like a social media platform which you're trying to build, and the source code is not GPL, you might be required to pay the licensing fee. And again, the most confusing thing is like some things don't have this 100K units cap, some have like 10,000, some have it even no device cap for royalty. At any case, if you're using the codec, you may be required to pay. That's the case of like, and instead of 20 cents at that point, it may be like $10 or $1. So it's pretty much complicated, and there are like 20 or 30 different encoding standards, and there are different bodies, and it's super complicated thing. And I'm not a lawyer, so I have a very little idea. So I just gave a quick overview about what's this royalty-free term. Because yesterday when I was talking to Vishal, he was a bit confused initially about the royalty-free term, and that makes sense because it's not a common word to be used in a normal talk. So I just gave a quick overview about what's this royalty-free, right? So that was a big introduction about like 10 minutes. That was not expected. So going forward, what's this AV1? So AV1 is the current generation media codec published by Alliance for Open Media. So this Alliance for Open Media is basically a organization. So what happened is that this royalty was a big thing in the old industry when all the companies had to pay like around 20 million every year just for using the video codec inside the software. So that added up big revenue to their business model. So what they decided is that let's fight this and we can form one organization to fight all of this. So what happened is that at this point, Google had their own implementation of royalty-free codec, which is open source, and Cisco had their own version, and multiple organizations had their own way to fight against this royalty patents and all these things. So that's how then they decided we instead of doing individual effort, we can have a joint effort And that's how Alliance for Open Media was born. And that's the behind the story. And with combining all the efforts, like Google had like 10% suppose, and Cisco had like another 10%. Combining both gave like 20% on a single thing. So that's how AV1 gained a lot of compression over the all available formats in the internet. And it's like if you compare the AV1 towards H.264, it's like around more than 50%. And if you compare AV1 towards the current standards in the sense like H.265, they have like around 30%. So that's the rough estimates. Even current studies sorry, show that the AV1 over the H.265 hardware model, which is built upon the hardware software, this AV1 has more than 20% efficiency over the hardware implementation of the video codec, the current best one in the market. So the AV1 software model is having around 20%. When the hardware is coming, it should be having more than that, just because it will be a bit more efficient. And this is the current Alliance companies is maybe bit. I think this is the current state. So there are many open, almost all the companies are there: Apple, Amazon, Microsoft, Facebook, Netflix, all the companies you can name, and there are tons of hardware manufacturers in the Alliance, just for making sure that the software people don't mess up when they're building hardware. So Xilinx and Netint and Argon Design are the main people who involved in the hardware design discussions. So when Google or Facebook proposes one model, they'll be saying like, we can't have this because it will be too hard for the hardware to implement. So it's like a joint discussion for building. It's a normal, at any case, it will be like a normal standardization body. So it's like in the case of decoding, it's super fast. And when I measured at some point the benchmark last month or 2 months back, the decoding towards with the hardware AV1 decoder from the NVIDIA inside the RTX 3090 series GPU, the software was quite more faster, even though the hardware would be having more memory efficient. Even then, the software is faster by around like, if when I was doing the 8K HDR footage, it was having like, the hardware was capped at 30 FPS, just because that's the upper limit of hardware which can do. And the case of software, it was like around 45 to 50 FPS, even though it will be using more power. So not last part, about the introduction about AV1. So it's like there are tons of hardware manufacturers which I mentioned, and these are the things which you have like in the modern Oppo, Vivo phones is having the AV1. Even the TV from the TCL or Motorola is having the AV1. Almost all places are having the AV1. Mostly this is through the MediaTek, because in the latest MediaTek process they have the hardware decoding of the AV1. Also the Samsung Exynos series chipset also has the AV1 decoding. So this is the some summary which I tried to collect. So like it's already there, the software is already there in almost all places, like the Android Q, it's already there. In the Netflix, it's already there. And Google Duo is already there. So like it's also supported these hardware decoding is there in the CPUs and GPUs. And yeah, almost all places you can think about AV1. And this is one slide which I have something from the MSU video comparison study of different codecs. So in this the reference X265 was made as baseline version. That's the hardware implementation, I assume. And comparing that, the AV1 encoder from Aurora, yes, that's a private company which makes private AV1 encoders, and that has more than like 40% improvement over the hardware version of the current generation. And comparing to the H.264, which I mentioned earlier, it was having like around twice the performance. Not even though it's not twice, it's efficient. So when we say it's twice or 40%, so you have like a 1 GB movie, you can give that 1 GB movie at like 40% lesser, so you can watch the 1 GB movie at the same clarity at like 400 or 500 MB. That's a big deal in almost all markets because you have the same quality at half the rate. So you can just make it like, so when you were streaming a 720p video at the same data, we can do like a 2K or 4K. That's one rough scaling we can do. The other one is like giving the lesser data. You can do like 720 at like for lesser data at the cost of 270 or 480, and the other is like having it at lower resolution. I mean higher resolution. Sorry. Yeah, that's one thing. And seeing again, like, and I mentioned at the beginning, it's quite hard. In the case of H.264, it took around like 7 years to become good. In the case of like H.265, it took almost same time. And the H.265 were mainly made by H.264 people. And then companies called Multicore, where it's having headquarters in, I think not headquarters, it's having a big office in Chennai in India. They do a big contribution towards H.265. That's the kind of open source implementation of H.264 standard, H.265 standard. And in the case of AV1, it was standardized in like 2018. And like I'll give a quick example, like for making a codec from scratch, the rough estimate people say is around like 10 years. And if you're making a video codec based upon referencing one software, to become a decent one, to have like some gains will be like around like 5 to 6 years. And to have like a around 5% gain in the quality, people say you need like 2 years. That's the thing which people say. Even if you talk to, that's the main problem with the video is like it takes a lot of time and effort for knowing that even the people who started into video back in 1980s, 1990s, even though they are old, so when you talk to them, they'll be say, I don't know, I just try to learn what's happening, even though they aren't even confident with the things because it's super hard and super complex. And like this is the main problem. Like adoption of the standard is the another problem which is yet to be solved. Even though like when it's a chicken and egg, classic chicken and egg problem. Like the device manufacturers are waiting for the content producers to produce the content, and the content producers are waiting for the device manufacturer to manufacture that. So that's the main problem which people are trying to solve, which is quite hard. Yes, last part. So how you can help the efforts. So if you are building a software, I try to list out some things which how the community can contribute towards the open standard efforts. So if you're building a software or a project, you can try to have a royalty-free video or audio solution. Or even if you're having some photos inside that, you can use the royalty-free video and audio, image solution. Sorry. So like the same things are in the image side also. Instead of doing for multiple frames, they just do for one frame and call it a day, and it's called like. And the MP for most of the things of H.264, like some skimmed down version of that is happening inside the JPEG. And it's similar case with the other standards, APEG, and then there is HEIC, that's the image format of H.265. So maybe you have seen that HEIC in iPhones and many other places. It's a rising thing. And similar thing with the AV1 is called AVIF. It's having the image version of the same thing, having like 40 or 50% over the previous generation image codecs. So another thing is like if you are a company or organization which has like a video storage or distribution, you can try to have a solution based upon the AV1 or any other royalty-free solutions for audio or video. That's one thing. And if you're thinking to do some research, and if you're a college student, you doing something inside the video compression is a very good start. And even though just prepare to invest some years into video, then you will be good to go. And then if you are a security enthusiast, you can try to reverse engineer and exploit the open standards. So the security aspects will be fixed. And then if you like to do some documentation, you can do some documentation part too. And yeah, so the whole talk was about you can say AV1 adoption is happening in good way, and the faster AV1 decoding is also there in almost all platform, even the normal x86 and the ARM is also supported. Then the older generation SSE3, SSE2 from the Intels are also being supported from the David with the almost same performance. Just because in the case of decoding, people say decoding is fast just because in the Videoland's David project is the main thing in the AV1 for decoding, and it has more than 180k lines of handwritten assembly inside the decoder just to make it fast. So people write almost, so the whole decoder main functions are written in assembly along with C. C is fast, and along with that they have handwritten assembly for almost all encoding functions. I mean almost all decoding functions, and that can be also used in encoders. So it's a joint effort from the encoding and decoding team towards writing hand assembly. And the case of decoder, it's more fast. You can directly use that and you get instantly good results. And yeah, adoption of AV1 is also happening in WebRTC space. Recently Cisco did show the demo, and it's already supported inside the web browsers for WebRTC AV1, and some others are trying to have the AV1 inside the WebRTC solutions. And last thing is academia body started to care about AV1, and that's how I ended up in academia too. And yeah, I think that's the end of the talk. I think it became stretched than the usual thing. And yeah, I think that's it. And a last sentence you can try to read in the bottom. A video makes around 80% people say. So if you have a 1% gain, or the quality translate to more than tons of GB, 20 EV, they say it's 20, and you have n number of zeros, and that's the current size of estimate traffic savings if you have a single 1% gain. So if you have 30 or 40% gain, the whole internet traffic will be reduced, and it may be a better place. And yeah, I think that's it. I'm more open for having some discussions and questions post this talk, and also offline if you want. And yeah, it was covering a lot of things. Some of things may not make sense, and many of things may be going on top of your head. And yeah, you feel free to ask questions. Thanks.
You are now unmuted.
Thanks, Vibhuti. So, does anyone have any question?
Yeah, so one question I have. Thanks, Vipit. It's
You are
very
now
interesting
muted.
talk. Reminds me of a multimedia course I did 2 decades ago, taking an MP4 and kind of taking the frames and applying fast forward transform, all of that stuff back in the
Oh,
days.
yes.
Looks like nothing much has changed.
Oh, yes.
So one thing I want to ask is what are other open standards royalty formats that are out there? I see there's OGG that's kind of there from quite some time.
Yeah.
So are there
Yeah,
any other
OGG
things?
is there.
How is the
Opus
adoption?
is there. The one is called Opus. Opus is the golden standard for communication inside audio. And if you see inside the YouTube is using Opus. And the current thing which we are talking, it should be Opus because it should be mostly through WebRTC, and the WebRTC's default audio format is Opus. And yeah, I think that's it. So there are many of the royalty-free video and audio standards are developed by the Zip organization. And yeah, the other things would be like the older generation. If you see, maybe like the Cisco's Thor decoder, and all of those things are combined in video space. It's combined to form AV1, and the audio space Opus is there, which is like reach quite in like super stable state and it's mature, and even Apple cares about Opus having. So that's a big deal inside audio space.
Great. I mean, so you're saying that people are not using MP4 MPEG anymore because it's royalty free and planning to use these things. Is that true? I mean, how much people use royalty formats, and what percentage of royalty free formats are used right now on the web?
So in the study of H264, which I mentioned, around 91% says about this, and it may be like 50%. In that, it was mentioned around 30% also for AV1 global usage. And in the case of like, if you compare all the royalty free things, around like 50% or 60% of the whole providers, including those of H264, provide royalty free contents. And people are not super happy to have only royalty free just because of some platforms may not be super supported. In the case of Apple Safari, they don't support AV1. They do support Google's VP9. VP9 is one of the like previous generation codecs, and the Apple added support only after like 6 or 8, 7 years. I think 5 years maybe we can say, about after the global adoption from people. And like yeah, so around 50% of the content producers, rough estimate what I think, globally do have royalty free for sure. And almost all the solutions might have some contribution from royalty free solutions.
Yeah, thanks. The other question that I have is when you kind of develop all this, write code to kind of write these encoders and decoders, so what's the default language that's used? Back in the days it was C++. Is it still the same?
Yeah, it's C++ and C. And in the case of our encoder in the zip.org, we have a Rust encoder called Ravi. That's one thing which is we are using, and it's already used in production inside Vimeo. And yeah, Vimeo people are also contributing towards the Zip's Ravi encoder. It's a fully and safe encoder written in Rust. So that's one good part of the community. People do care about Rust too, but adoption of Rust thing may not happen. I think some people are a bit hesitant towards having a non-C version or like something which is unconventional inside their production pipeline. But Twitch did show some liking towards our Ravi project, and they were thinking to adopt. So people do care slightly towards other languages apart from C, C++. And maybe what we can say, like the David decoder is fully written in C99 or C89, mostly C99 standard. It's mostly C and C++, and there are some exceptions like our Ravi project from Zip.
Yeah, so I mean, sorry to kind of divert. Like, do you see like a lot of productivity when you kind of switch from C++ to let's say Rust when you're writing this stuff?
Yes, so the good part of myself is like I find reading Rust code to be cleaner. Just another reason might be like it's written from scratch from the encoder, because you can't have a C code to have a fully Rust encoder. So because the encoder pipeline is complex, so the whole thing was written from scratch, and it's so due to that it's a bit more modern. It's better readme and structure of the whole project. So in that case, it's good. Case Rust is good, better.
Like, I was really talking about when you can write code in Rust, right? I mean,
Yeah,
especially for the kind of project which are kind of quite low level, all you're doing is kind of number crunching and doing Fourier transforms and then transforming frame to frame and coding all of that. So,
yeah.
does a language like Rust, its types and all that, does it add makes it a lot more easier to kind of reason about the code than what low level C can offer?
Yes, what I felt in the case of Rust is that I felt it's bit more easy to debug the whole process. So in the case of decoding, like in the case of encode U, encode I, in the whole picture is something like in the case of FOSS United, the logo in the left top may be messy and this thing might be having like it may not be properly encoded, and decoding like tracing down the whole thing for a Rust project, I felt it was bit more easier because we do abstraction of the things like in different classes and different grades, and due to different sub projects inside the whole project, it became a bit more easier to trace down. And what else I felt like, so the good part is like you are building a new coding tool inside the encoding pipeline, and in the case of Rust you just need to use that use that file, use that folder, and you have the whole functions just like C headers, but slightly more easier for new people to get started inside video is Rust for sure.
Yeah, thanks. I mean, I think we're just kind of curious to kind of see, because especially in academics and these things, like things change really slow. Uh,
Yes.
that's why we're kind of curious about like how are they kind of adopting a new language like Rust. Yeah, thanks.
Oh yes, so like in the research lab here, I tried to propose using the Rust version, and people were really interested to start doing some research towards the Rust version of the encoder. So what we are planning to do is like we'll be doing the things in C, and then along with that we'll be also trying to have that inside the Rust version. And when we are publishing some papers or some research, we'll be having the Rust version along with that to compare. That's the one thing which we are planning. So academic people are at least interested. Maybe at least here, the lab here. That's I'm working in a sync media lab inside Trinity College. So it's inside the electronics department. I was a computer science graduate in bachelor's and now inside the electronics. So it's a steep learning curve for me.
Nice, nice. Yeah, thanks a lot. I think it's quite interesting to kind of see the contrast, and this is something that we usually don't hear. We only talk about stuff that uh, um, I mean, so this is a new kind of stuff that we're hearing today. Very nice to kind of see that that kind of diversity today, diverse talk today. Thanks a lot.
Alright, thanks. Also, in the future, we can, if the people are interested inside video space, we can have like a specific part of the encoder or decoder of the video pipeline and discuss about that. And we can plan something in the future too.
Yeah. So something that would be interesting is if you can actually figure out a way where you can actually new people can come and contribute, which is kind of not it doesn't have to understand so much of math, but something in the surface so that they can get started with that easily, right? I mean, improving the build
Yes.
pipeline or something like that. I mean, something which is kind of not to core to your product, but then I think we have a lot of people in the first commit group may be really interested to kind of join and then contribute to the project.
Right, yeah. So in that, one thing which I think is that there are a lot of things which are kind of dependencies towards the encoder. One is like the analyzer. That's the bitstream analyzer, it's called. So we provide the decoded video and provide that inside the website. That's called AOM analyzer. We just provide the video which is encoded, and it will do frame by frame per details of all the pictures inside the frame analyzer. It's a web thing, and yeah, it's quite fairly straightforward, and people do contribute towards that, new people. And we did GSOC this year, and there was one GSOC student who tried to work on the analyzer, and there was another GSOC student. So in the zip we had 3 GSOC projects, 4 GSOC projects, and the video line we also had one slot for the AV1. One we shared the slots. So in that, one was like the analyzer part, which the new people contributed, and the other things is like trying to build some metrics porting from which was a C++ thing and making that into Rust version, which is like fairly rewriting the whole thing inside the Rust stack. So there are a lot of space which new people can contribute for sure. Just need to write down and make a to-do list for what people can do and have a list of things what they can do. There are a lot more things like RV compressed yet, which is like a web-based player to analyze post-encoded results, which is a super bad thing. Bad thing in the sense like the code base is bad. It's like around what I can say like even thing is like it may be having like an 800 characters long AWK statement because people are too lazy to write, and that's called inside a Python tornado, and it's having so it's a bloody, it's a super stupid architecture which all the people uses that requires a lot of revamp and contributors. So maybe we can list out things which people can contribute and we can get started. Which has little to do with the max or science inside and Coda, but it will be super useful for the community.
Thanks. I think that would be really nice if we can do that. I'm sure we can touch base separately. I think Vishal or even Devdutt can join and discuss and see. I think there's a lot of value we can see for the first commit group, where I'm sure a lot of people may be interested to kind of do that. Okay. Devdutt, do you have any comments?
Yeah. Devdutt tried to do something with the encoder for like 1 year back or 2 years back.
Yes. I've not looked back at encoder stuff ever since.
Just move it forward from the mic.
How about now?
Yeah, it's perfect.
Okay, yeah. So what I was saying is I have not looked back at encoders and audio-visual stuff for some time now. But yeah, so going back to what Anand pointed out, it's very obvious that we have a lot of scope here to like talk about all the complexities that are possible to like learn about and methods through which people can contribute to the project. Especially since this field, that is especially video encoding and like network traffic and things like that, it's going to be very helpful as a skill development program as well. So people will take that as a positive, I believe, right? They can apply their skills to jobs and outside like open source contribution as well, I believe.
I think so, yeah.
Yeah, so that could be one way we can apply our scope. Yeah, what do you think would be a good way to like get new contributors from your experience with GSOC program?
So maybe good way to get started is having good first issues. So that's one thing which we can work on. We can work on having good first issues towards the encoders and decoders which people can contribute without requiring to learn the in-depth about encoders or
like get new contributors
like
from your experience with
software
GSOC program.
Post encoding, which is more of like a data analysis and data parsing, data visualization. And maybe good way to get started is having like good first issues, non-web projects. So that's one thing which we can work inside the encoder, just rewriting some things into Rust. And there are a few things like that. I think that can be a good starting point for people to get started.
Yeah. Another question that I get right now is video right now is becoming more popular. People are using video in almost all aspects of be it in something like a TikTok clone or in like YouTube videos or maybe in just like live streaming and even in the case of like what we are doing right now, video conferences. So it's going to be very important to like build tooling and in that manner, how do you think is it's important to understand the basics like AV1 or let it be any other encoding format? How important is it to understand these formats, these standards, instead of like using just plug-in tools?
I see it's like more like a lot of people do machine learning things and rarely people know how the actual logistic regression or the quotient process works, right? So hardly people know those parts, and but still it works great. But they do have a surface level understanding about how it works instead of knowing the actual maths inside the machine learning models. So I think it can be also classified similar. They just need to know how the overall video compression pipeline happens, so they can do some work and use this. So they can. So it's the reason I'm saying to know the whole pipeline is like if something crashes, if they don't know the fundamentals of the whole high level understanding of video compression, then it would be quite complicated. Even though it can be done without fully understanding video compression, but yeah, it can be done too. For building the WebRTC project for video conferencing, you hardly need to know how the video works. You just use you just use the code and have it in the right place, and you are done. You are good to go. You have the stuff done. But for having something like if you are having a video cut player inside the web browser, having a frame accurate cut, you are not going to have a frame accurate cut without knowing how the video process work. Or the last thing which I will say is like you can do the things, but it may not be optimized. Like you can do the whole thing, it may be using like you may be serving in like a non-optimal, suboptimal way, where you may be using like a 2 GB, where the things can be done like in a 1 GB. But for starters, they can do that, and they later only they can approach some people who know video to fix those things in a nice way.
You are now unmuted.
Devdutt, do you have any follow-up questions? In case you are speaking, you are on mute. Okay. So anybody else? Ganesh, do you have any question or somebody else? Ravish?
No.
No, thanks. So thanks Vibhuti a lot to joining us today and talk about some like Anand mentioned a diverse field that we saw very little earlier. We never even I was talking to you in personal like chat like we never had a session on topic like video and audio encoding because like there are a lot of projects coming with audio and like they just mentioned, right? We have TikTok clones coming. We have a lot of meeting applications coming, GeoMeet and stuff. So it's good to actually have the idea about this space as well. And like I mentioned yesterday, I would love to mention about AV1 in the upcoming hackathons. Suggestions, notes where in case somebody is trying to build something audio video related, so they can make use of AV1 and other open standards. So thank you a lot, and if you have for the audience, if you still have some question, you can. So he is in our Telegram group, so you can ping him as well. He's available there as well. So
Yeah, Vishal, one suggestion: we should uh, hold Vibhuti and then make him a mentor for a hackathon. I'm sure we can push some people to do try some projects on AV1.
yeah. What do you think, Vibhuti?
I'm fine with that. I do like I've been doing a lot of things in the home university in the past, right? So I think it should be okay. Maybe some people, I think Anand, people might know about the Amrita FOSS and the initiatives from the club.
A little bit. I think I remember kind of discussing with some people back in the day when I was doing PyCon India. They used to be very active.
I remember. I think there was one person in the cybersecurity space called Aravind. He may not know you.
Yeah, I don't remember people's names, but
Yeah.
I remember kind of getting in touch with people there. I think when we did the Python workshops, Python month, etc., I think we did some in Amrita College as well. If I remember correctly. Back in the days, I think it was like more than 7 years now.
Yes, yeah.
So yeah,
Cool.
thanks.
So there's one question.
Yes,
So
yes.
anything being developed in peer-to-peer video transmission domain? It's like maybe I can say I think the video compression video standards are already there, and these codecs can be used in almost all use cases like peer-to-peer. I assume peer-to-peer in the sense like the normal 1:1 video chats. Is that being referred?
You are now muted. You are now unmuted.
Can you
That he's typing.
just speak CVS? Okay.
All right, so reducing bandwidth cost of a single server. Sure. Yeah, these the things which is being said is like it can be done in 1:1 chats. Like in the case of like Google Duo, they are using AV1 for low when when the person is in the low bandwidth range and it is like sub 1 Mbps, they are using
You are
AV1
now
for video
muted.
compression video chats in like 1:1 video chats. That's what's happening inside Google Duo and AV1. That's one thing which may be interesting for you, and it will always reduce the bandwidth cost of single server.
I think his point is usually when you make video chatting, it goes to server and then if A and B are communicating, A sends video to server, server sends back to B, right? Instead of that, then there's a way to connect from A to B directly, okay, without needing a central server. The server would just coordinate the initial communication and then
Yeah,
stay away from.
that's
That's
how
what I
most
think
of the
talked about.
time WebRTC happens, right? They have a like different protocols is like they give a things towards the server and server has the coordinator towards the end, and both people do the guy sends there towards this person and the coding happens in this on the fly. On both ends it happens on their own end. I assume that's what I think. On like the server just would be transmitting the data, the any encoding or decoding process the server won't be most of the time doing. They're just transferring the bandwidth from one place to another.
You are now
I hope
unmuted.
this clears the question of CVS. And okay.
Yeah, if there is some question we can have in the chat in the group.
Yes, yes,
Of course, we can take it offline. It may be late.
Yes. Yeah, sure. So yeah, thanks Vibhuti, thanks CVS. So next, thanks Vibhuti again for joining today and giving us idea about video space. And like I mentioned, we'll make sure that we are keeping this in mind while hackathon is happening. So next we have Vishnu. So he just won the Code-a-pookkalam event that was being being happen on that actually happened on Mon School to so the in case you are new to Mon School and Joy programming, so basically I guess it's better if we hear from Vishnu. So Vishnu, can you share your unmute yourself and share your experience with Code-a-pookkalam and Joy library?
Yeah, sure.
Please first introduce yourself. Sorry, yeah. Please.
Okay, so big thanks
You are
to
now muted.
FOSS for inviting me to this talk, and myself Vishnu VS, and I'm a first year computer science student at Marine Engineering College, Trivandrum, and I'm a self-taught full stack and app developer, and I'm still learning and exploring new things. Now I'm into my own startup named Ideologics, and I'm also a biology student. I was also a biology student, and and when talking about my experience with Code-a-pookkalam was pretty awesome because I got a lot of experiences on both projects wise as well as the community wise. Actually, I started programming at my 11th standard on a mobile phone since my laptop wasn't capable for doing some programming related stuff, and I tried some way to do it using mobile phone. And I learned most of the programming languages and new Linux terminals and all these kinds of things using mobile. You know, during the contest, I had no idea on what to do. First, I thought to do it like a 3D view, and I tried searching for sample Pokemon designs for ideas, but none of them were satisfactory. And later, I came into this idea, and but I had experienced a lot of difficulties while coding for this contest because I had to rewrite the entire code of couple of times since the website often gets down due to traffic and all. And especially thanks to Anand sir for making this site. And I somehow managed to complete it on time, and thanks to that also. And the final results were shocking for me. I didn't expect that I would become the winner of this contest, and I'm very thankful to everybody. Thank you, and I really miss these communities at my schoolings, and I never know that these communities exist or not. And yeah, if I knew, I would have improved my skills way better, I think. And for that, a big thanks to everyone for once again for a big thanks to everyone to for inviting me in this talk. Thank you.
Hi, Vishnu. First of all, thanks a lot for actually participating and kind of creating submitting such a wonderful entry. Do you mind sharing your video so that everyone can see you and kind of ask more questions?
Yeah, sure. Let me try.
And if you can share your screen as well, and then see if you can show the content, your entry yourself, okay? And probably walk us through the code a bit, like how you kind of crossed it, etc. Then that will be wonderful.
Okay, okay. Let me try. So.
You are now unmuted. You are now
Maybe
muted.
Vishal can try to share the code so
You
he
are
can
now
also
unmuted.
say instead of key sharing.
Yes, I got some technical issues. That's why. Sorry. And
Yeah.
yes, yes.
Yes.
Yes, yes, yes.
To walk us through this code. I mean, how you made it? I guess that's what Anand asked.
Yeah, sure, sure. I'll explain. I try to explain. Okay.
Yeah. Thanks.
So, this it was really a nice experience on working with Joy library, and it's pretty easy. I think everyone can learn by easier way. And what I create a new uh, uh, two new what functions to draw with using new objects and You might have seen that fill and stroke functions that I coded here, and and these other things. I divided all these code into separate functions to make it more usable and what to make it more readable. And I've tried I think I've tried well documented all these things to make you understand what is happening behind the scenes. Yeah, that's all I think.
Let me just come to my screen. Stop sharing a screen. Perfect. So yeah, I guess the documentation part, that's what make Anand, and other jury members to understand the whole, program that you have written. And
Yeah. Yeah, so let me add something. Right? I mean, so one thing that I really liked about the code is it was really kind of really nice to kind of see. So when you read the code, right, you kind of understand how a cooker is really made in physical world, right? You actually, so if you look at the functions, right, you kind of it's kind of so well organized. Like I was really kind of amazed by that. So you actually started with creating a base with cow dung, and then I mean, there are a lot of these names in Malayalam I couldn't really follow, right? For example, there are what is it called? I mean, just trying to kind of read through it, read through it again. Moment, can I share my screen,
yes, yes, yes,
Vishal?
yes, yes. Now you can share. Yeah.
Moment,
And it should be the flower names which you are mentioning.
yes, no, no, not only flower
The
names. I mean,
3D version of what they have separate name for that.
Ah, yes, okay, I can see Narkolam. Fair enough.
yeah. Yes. Okay. So just kind of going through this code. Let me know if you can see that. I mean, so there are like three kinds of flowers that you use. I kind of know that you have used jasmine, rose, and another flower type called jamanti. I don't know what that is, but it's kind of clearly nice that you have
You are now
uh,
muted.
uh, created a cow dung base, and then I think if you look at the inner. It's a. I forgot where it is, but I think there was place where you actually start with yes, yeah. So the inner one that you can make, right? When you start with a cow dung base and then kind of create a this kind of different. So you create a cow dung, I don't know, some flower-like thing, and then kind of create multiple flowers, rose flowers and geometry flowers, and then kind of that's what makes inner thing, right? So it's kind of very nice to kind of see that. Okay, the intent, like what you're trying to do, is kind of reflecting in code. I think that's really a very important skill, and I'm really kind of quite happy to kind of see that in the submission. And okay, and also like your persistence to kind of try making it like a 3D thing. Okay, even though you didn't submit that finally, I think that really it's very nice to kind of see that. Okay, and really apologies to kind of not able to keep the site up all the time and make you lose your work once in a while. But I think I hope overall it was worthwhile experience. So, Vishnu, I want to ask you one thing. Right? I mean, uh, you mentioned that you learned a lot of stuff on mobile phone, right? Okay. How was that experience? I mean, was it like too difficult? Just get curious to kind of understand. How did you learn on a mobile phone, programming on mobile phone?
Uh, Actually, I didn't felt any difficulty in coding inside mobile phones because I used from the first to code that one, and my laptop was not enough. Uh, which is a kind of an old laptop. That's why I tried to learn using mobile, and I use various apps to program as well as to learn all these things. And I always read the documentations and other blogs, etc., to keep me updated. And I follow some developer communities, not communities, some developers who share their experience and knowledge in Instagram. And these are the things I follow. And my favorite application is Thermex, which is kind of a Linux terminal. And through that, I try to install all these SDKs and compilers to run my code, etc.
On a mobile phone, is it?
Yeah, yeah.
So, I mean, did you actually write all of this in a mobile phone?
Yes. Actually, this was written in first I written the flowers using the mobile phone, and later I transferred it to the PC. At the first, it was not. I got some crashes in my laptop because it's not. The codes itself requires a bit more computation power that my laptop couldn't stand. I got some errors and internal crashes, uh, but somehow managed to work all these things. You know, that's
Wow,
what.
wow, it's really nice to hear. So I hope the prize that you're going to get would solve all the problems now, I believe, right?
Yeah, sure.
Yeah, really
Yeah,
nice. So for those of you who don't know, like the first prize is a MacBook Air. So I think he's going to get an M1 MacBook Air if I remember it correctly.
You are
Okay.
now
Yes, it's
unmuted.
M1. Yeah, Air.
Yeah. Have you already got it or going to get
no,
it?
no, no, no. I get it on 16th, I think.
16.
They told.
Yeah, really nice. Okay. So, Vishnu, one thing that I
You are
really
now muted.
recommend you is to, I mean, I think I mentioned to you even before you actually uh, made your submission, right? Okay. When you're making your sketches before even the contest started, to see it would be nice to kind of see if you can create a library called Pookalam. Okay. If you look at the kind of patterns that are used, there are three kinds of flowers and then creating different bases, etc. And there are other people who have died different ideas, right? You can compile all of them into a library called Pookalam, okay, an open source library,
Yes, yes.
which
Not only in this project, I usually make my own libraries because I don't use GitHub much, and all other third-party libraries. I try my maximum to make it my own. That's what I did like this.
so what I'm suggesting is like, can we kind of it would be a good project to kind of try creating a library called Pookalam, okay,
Yeah, sure.
on
I
top of
agree.
Joy, which will basically take all the patterns that you've done, for example, right? How do you create a define the colors for cow dung and other stuff, and then create a rose, jasmine, and different kinds of flowers, okay? And then, for example, lamp, right? A lamp is a very, very nice function to be there in that library. People can actually take a lamp and put it there, okay? And then write a bunch of tutorials about how to create Pookalams with code, right? I mean, I think that's going to be really wonderful, okay? Especially for people who are completely new to programming, especially people from Kerala, right? I mean, looking at creating Pookalams as a goal to kind of learn programming is a really wonderful idea. I think if you can start with creating a small library Pookalam, I'm sure like we can actually ask all the participants who have done to come and contribute. I think that's going to be very wonderful open source project. Okay, so one thing is generally like free software, right? I mean, why do kind of people create free software? To kind of scratch their own niche, right? I mean, so usually we find open source projects which are originated in other parts of the world, right? I mean, they generally kind of solve a generic problem, but not something very specific to needs of people in India or let's say Kerala, right? I mean, but I feel like this is a very great opportunity, which actually is a problem, not a problem per se, but actually helps something that's only very specific to Kerala. I think it's going to be really wonderful project if you can actually attempt that.
Yeah, sure. I'll try to upload as soon as possible, sir.
Yeah, no, I'm happy to kind of help. You can ping me if you need any help. Okay, happy to help anytime. Okay,
Thank you,
or
sir. Thank you.
I'm sure you can ping in either the first commit channel or uh, the FOSS United Telegram group. I'm sure like many people will be happy to do. Okay, I think if you can once start and kind of share it with all the people in the group, we can actually share it with all the people who created Pookalams, and kind of ask them to kind of contribute. For example, I'm sure like there are many people who have done wonderful work, and because only were able to get only one prize, okay. But I'm sure like there are many other people who have really created wonderful Pookalams, right? I mean, I'm sure like they may actually give some of their code, submit as a pull request to your project, okay. So that way, like we can actually have a very grand Pookalam library that someone who's completely new to programming can actually take and actually create a beautiful stuff. Yeah, that's all from me. Anyone else
You
have
are
any
now unmuted.
questions or comments?
We have a comment in the public chat box. It's from Ganesh. So yeah, I mean, it was a great actually to see somebody who was in bio background and built this beautiful Pookalam with keeping every a specific thing in mind while writing the program. So it's good to see, and I'm very glad that and you are here to talk about your experience. So thanks Vishnu to join this Saturday with us, and we have the next meetup on coming month, second Saturday, same time 2 p.m. So thanks everybody. In case if you have some question, we can take this to the public group for any other discussions. Thanks. I'll just end this meet and video stream. Just give me a second.
You are now muted.